Imagine a bridge. It is built one plank at a time. Every single plank is inspected and found to be strong. The carpenter who laid it followed every rule. Yet, over time, the bridge begins to sag. The structure fails not because of a single weak point, but because of the accumulation of small decisions. This is the reality of software engineering at scale. It is a common misconception that bad code comes from bad engineers. The truth is far more subtle. Good engineers often write bad code because the system rewards them for doing so. Here is the thing. We tend to blame the individual when we see a bug or a slow system. We assume the person who wrote the code did not know better. But in large organizations, the incentives are often misaligned. When you are measured by objectives and key results, which are targets set to track performance, the focus shifts to shipping features. Refactoring code, cleaning up technical debt, or improving architecture does not show up on a dashboard. It is invisible work. So, a smart engineer facing a deadline will choose the quick path. They write code that works now, even if it is messy later. This is the beginning of what we call incremental decay. Now consider this phenomenon of bad days for developers. You might think a developer has a bad day because they are tired or distracted. Research shows it is often the environment. Context switching is a massive killer of productivity. If a developer is interrupted constantly by meetings, or if their build tools are slow, their cognitive load increases. They make mistakes. They write code that is harder to maintain. It is not a lack of skill. It is friction. When the tools fight you, the output suffers. This is why continuous integration and continuous deployment pipelines sometimes fail. It is not always the code that is wrong. Sometimes the process around the code is broken. Think about the rise of artificial intelligence in coding. Large language models can generate code in seconds. This is incredibly fast, but speed comes at a cost. An engineer might accept a block of code generated by a machine without fully understanding the logic inside. They might not realize it contains a security flaw or a performance bottleneck. The code looks correct, it passes the tests, but it adds hidden complexity to the system. This creates a new form of technical debt. It is debt that you cannot see until the system is under pressure. The engineer is good. The tool is fast. The result is fragile. There is also a strategic element to writing bad code. Sometimes, a competent engineer will intentionally write suboptimal code. Why would they do that? Because the bureaucracy is too heavy. If you need to change a core system, you might need approval from 10 different teams. That process takes months. If you need to test a risky idea, you might write a quick script that lives in a corner of the system. You isolate the risk. You write bad code on purpose to bypass the review process. This allows the company to move fast, but the bad code stays there. It becomes a legacy system that nobody wants to touch because it is too dangerous to modify. This brings us back to the decay. Every time you take a shortcut, you are borrowing from the future. You are trading maintainability for velocity. In the beginning, velocity wins. You ship faster than your competitors. But over years, the velocity slows down. The system becomes so complex that a simple change requires weeks of work. The engineers who started the decay are often gone by the time the consequences hit. They moved on to the next project. The new engineers inherit the mess. They try to fix it, but the cost is too high, so they add another layer of workarounds. The decay accelerates. Here is the thing that is often missed. We try to solve this by training engineers better. We tell them to write cleaner code. We tell them to follow best practices. But if the system rewards speed over quality, no amount of training will change the outcome. The individual is rational. They are responding to the incentives. If you want better code, you have to change the incentives. You need dedicated time for re-engineering. You need metrics that value quality, not just feature delivery. You need to treat technical debt like a financial debt that must be paid down, not ignored. Organizations often mistake technical debt for a temporary shortcut. They think they will fix it next quarter. But next quarter never comes. The pressure to ship new features is constant. The culture shifts. Good engineers become cynical. They stop trying to improve the system because they know it is futile. They focus on surviving the next sprint. This is a systemic failure, not a behavioral one. So, how do we fix this? We need to acknowledge that code quality is a product of the system, not just the person. We need to stop blaming the engineer for the decay. We need to look at the tools, the processes, and the goals. We need to understand that sometimes writing bad code is a rational response to an irrational environment. If you want to build lasting software, you must build a culture that values longevity over speed. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.